Recording in progress.
Okay, so here's how the Polodoku puzzle works. It's a way of doing polynomial division. So this is a way of doing polynomial division. I mean, you guys have multiplied polynomials in the past, like foiling, right? You guys have added, subtracted, combined like terms. The division part's kind of weird, but really, it's just factoring. That's really what it just is. So before we get too deep into it, you don't have to write this down. But let's say I gave you something like this here, right? Oh, geez. Do you guys know how to factor that? How would that factor? X plus 1, x plus 4. Good. Now, what you could do also is make a little box here, right? You could put x plus 1 here, x plus 4 here. And notice that you multiply x and x to get x squared, multiply x and 4 to get 4x, multiply x1 to get x, multiply 1 and 4 and get 4. Notice in the upper left corner is the leading term. The lower right, sorry, the upper left corner right is the highest term, the term with the highest degree. And the term on the lowest right corner is going to be the constant. And notice this diagonal here have like terms, right? X and 4x, those are like terms. And they add the 5x. What if I do something a little more drawn out, like say this one here? Let's say I were to multiply these two out. So you do the same thing, right? Just to make a longer box, right? And again, I'll put x and 1 here. X squared, 2x, and 3. So what's x times x squared? X cubed, right? That's x squared. What's x and 2x? 2x squared. What's 2x and 1? 2x. What's x and 3? 3x. And 1 and 3 is 3. Notice again, the upper left corner is a leading term. The lower right corner is a constant. And notice that these right here are like terms. So if you combine it, what do you get? You get x cubed plus 3x squared plus 5x plus 3. Okay, why am I doing this? Okay, let's go back to very standard math, like 4 times 6. What's 4 times 6, guys? Good. Okay, good. I was getting a little worried. No, I'm just kidding. Now, what if I did 24 divided by 4? What would you get? Oh, well, sorry, 6, right? It's the same thing. What if I took this guy and divided by x plus 1? If I divide that polynomial by x plus 1, what would I get, guys? What did we just multiply x plus 1? It's right there, staring right in front of you. What did I just multiply x plus 1? You guys see that, right? Okay, good. Maybe just you're too afraid to answer. If you divide x cubed plus 3x squared plus 5x plus 2 by x plus 1, what do you get? You get x squared plus 2x plus 3. Because remember, this is the product, right? All the stuff in the middle is a product here. Everything in the little grids here is a product of these two polynomials being multiplied. But if you take the product and divide by one of the things you multiplied by, you get the other thing you multiplied by, right? And that's what we're trying to do. We're trying to reverse engineer this process. We're trying to figure out, how do I actually get this through division? That's what we're trying to do here. That's the whole point. And in some ways, it is factoring, right? Because you're factoring out x plus 1 to get what's left over. But it's more of a mechanical way of doing this. It's not as seamless as other types of factoring we've done in the past. So we're being more intentional about. Alex, go ahead. Oh, sure, no problem. Here we go.
Thank you.
Okay, so let's try it for part A. Here's what's going to happen. So part A, now I have 5 terms here. So I'm going to do, actually, I think I did too many. I think I did too many columns. I think I only need 4 columns. Okay. So what I'm going to do is going to put 3x and minus 1 here. Now on the outside is 6x4 minus 5x cubed plus 10x squared minus 18x plus 5. Okay. So all this right here is supposed to be all the stuff in these grids here. When I combine everything in these grids here, I'm going to get this. So your task is to figure out what goes in each of these four things above. That's your job. That's what you're supposed to do. But here's what we know. Here's a pattern we noticed. What's the leading term here, guys? So that should go right here. What's the last term, guys? 5. That goes right here. Now you're going to reverse engineer. It's not that hard once you get the hang of it. It's actually kind of cool. What do you multiply 3x get to 6x4? Perfect. Thank you, Alex. And now you got that. What do you multiply 2x cubed? When you multiply these two together, what goes in here? Yeah, see, now we're rolling. Okay, let's roll here. Once one domino falls, all the other dominoes fall, right? This is good. Okay, take a look at the x cubed part. That's negative 5x cubed. What has to combine with negative 2x when you combine like terms? What would you add or subtract from negative 2x cubed to get to negative 5x cubed? What would you do? Yeah, negative 3x cubed. Yes, you got it. Yes, good. Let's keep going. You see how all this becomes that, right? You keep moving now. So it's rinse and repeat. What do you multiply 3x to get negative 3x cubed? Negative x squared, exactly. So what we're doing is we're actually factoring out 3x minus 1 from this big polynomial 6x4 is the leading term. And then that becomes positive x squared. And if I have positive x squared, and that's 10x squared, that's 9x squared. If that's 9x squared, that's 3x. If that's 3x negative 1, that's negative 3x. If that's negative 3x, that's negative 18x, negative 15x. And then therefore that's negative 5, and boom, negative 1, negative 5 is 5. I got it now. So this answer is going to be 2x cubed minus x squared plus 3x minus 5. That was actually the whole essence of what we did yesterday. So if you weren't here yesterday because you're doing the test, you've pretty much now seen it. This is, and actually, I will admit, I didn't do the best job teaching this because I was actually, I'll be honest, I didn't really look at the notes. I was going on the fly. But as I did it with D period, and I've thought about it and reflected overnight and thought about this morning, it makes more sense to me now. This is actually a really cool way of doing division. Actually, it's much better than some of the other techniques I've taught in my lifetime of teaching this stuff. So this is actually a really cool technique. This is polynomial division. It's like factoring, but you're being more mechanical about it. Now, there's other ways I taught as well. I'm going to show you the other ways just a sec right now. And then we'll just talk about the rest of the homework. But that's what you have to do for this kind of stuff here. Now, other ways you could do it, don't write these down. I'm just recording. You can watch the recording later. You could do something called long division, which part of my language is a total pain in the ass. I really don't like it. The reason I don't like it is as a teacher, these are a nightmare to grade. But I'll show it to you anyway. If anyone remembers what we did in class, and that's 18, by the way, sorry. If anyone remembers what we did in class, do you guys remember how I did this process? So basically you have to figure out what to multiply to 3x to get to this, right? Same thing, 2x cubed. Then you multiply all this by 2x cubed. But this is the part where it gets messy. You have to subtract what's in blue with what's in pink. Of course, the leading terms, that's 4, sorry, my bad. The leading terms cancel. Negative 5 minus negative 2, that's where people make mistakes with all the negatives. It gets really messy, is negative 3x cubed. Then you say, ask yourself, well, what do I multiply 3x, get negative 3x cubed, negative x squared. And you kind of just rinse and repeat. If you go, okay, well, let me bring that 10x squared, negative 3x cubed, plus x squared, subtract it, 9x squared, minus 18x. Do it again, plus 3x, 9x squared, minus 3x, negative 15x, bring it down. It just gets crazy, you know? But you get the same thing, right? And you get no remainder at the end. I like the box better. What do you guys like? The box or the what I did? Right. Yeah, and some teachers who don't know about the CPM stuff, they teach it this way. They only teach it this way. Now, I've taught it this way for a long time, for many years, but I like this boxing. I think it's really neat. It's really kind of a cool way of doing it. Can I have a question? Yeah, go ahead. Yeah, fire. Can I what? Yeah, I'm gonna go over. Yeah, I'll go over that in a sec. Yeah, actually, I like be a little better to go over because I should do that. Now another technique, yet again, is something called synthetic division, which I think is a little better in long division, but I still like the boxing better. Or the Polodoku, if you want to call it that. The way this doesn't work for this particular problem. So let me backtrack. I'll have to do it for part B. Okay, part B. So Ben asked about part B. Let's do it right now. Okay, I'm not gonna do long division anymore today because I don't want to. Because I don't like it. So I don't want to. All right. Here's what you do. Whatever your degree is 4. I'm going to do 4 columns. If the degree is 2, do 2 columns. If the degree is 3, do 3 columns, so forth. So I'm going to put x4 here. I'm going to put -4 here. Put the leading term in the upper left, constant. And it's a constant, not the last term. It's a constant goes in the lower right. And I'll put x and -2. Okay, let's get it done. What do you multiply x with x4? That's -2x cubed. And then because you have -6x cubed, okay, careful. This is where you have to think hard, guys. You got to focus. -6x cubed, what goes over here? What do you combine in -2x cubed? Not when I say combine, what do you add to -2x cubed to get to -6x cubed? Yeah, but it's got to be negative. Thank you, Monty. And then that will be -4x squared, 8x squared. Then, do you see? Okay, so this is the part, Ben, where you probably are confused, I'm guessing. Is there an 8x squared here? There's not. So it has to cancel. So what are you going to put in the diagonal right above it? Yeah, there you go. That's -8x. And then that'll be +16x. Therefore, that's 2x. That's 2. And just to check if it all makes sense at the end, it does. We're good. We're awesome. We got it now. Does that make sense, Ben? Yeah. But, it got skipped over. We have to be mindful about it. Okay, C is kind of a funky one. Excuse me. C is a funky one. Let's do C. Okay, the degree is 3. So I'm going to do 3 columns. 1, 2, x, -3, x cubed, and 3. Okay, this has to be x squared. Let's keep going. -3x squared. Then you have x squared, so this has to be 4x squared. So that's 4x, -12x. Then -2x, right? Correct? Yeah, that's -2. But here's the problem I run into. What's -3 and -2? That's 6. So that's a 3. So what this means is that there's something left over. So that's a 6, but we really have. Okay, that's my messy handwriting. I apologize. Do a text box. It's supposed to be 3. So we overshoot the constant by 3. Hence, we need to take away 3. So here's what you do. The answer is going to be this. X squared plus 4x minus 2 minus 3 over x minus 3. It's actually a remainder. It's actually a remainder because you have to take it away. Okay, so what's left over? There's a way you could check your work if you so desire. You could always multiply this by x minus 3, see what happens. You could do that. If you do that, you'll get a negative. So if I were to multiply all this by This is the part where it gets a little messy with the algebra, so just bear with me. And you got to really just have intense focus here, guys. I'm not saying you guys are not focused, but if you were actually multiply this out, it's a pain in the ass. I get it, but you would get x cubed. You would get plus x squared. You would get minus 14x. You will get plus 6, but you'll get minus 3 at the end. And that minus 3 counteracts with that 6 to bring it down to positive 3. So that's what you have to consider when you do this, is that you have to realize the last one is going to be off. Sometimes it might be. If it's overshooting it, takes them away. If it's undershooting it, add it on. And that's what you got to do. This is how we do it. So it's kind of a cool way of doing division. I think it's really neat. Let me show you the answer for part D, and then we'll move on to the parts of the homework. But hopefully those who missed, hopefully you guys get an idea of what we did now. Now, hopefully this makes a little more sense. Actually, I think I'm teaching it better too. So, anyway, part D, had no remainder. There we go. 8, 120. Here are all the answers for 8, 120. Let's see if I could do this technique again. So let's go to 8, 120. Let's do it again. Okay, so let's use polynomial division. Okay, great. So this is actually important. We talked about this too, guys. So what's the big polynomial here? It's going to be this guy, right? And what do they tell us? They say it's a solution. What does that mean? Okay, this is huge. This is I went at the beginning of the year when I talked to you guys, like, what's our goal for this class? Our goal for this class is to learn. Yes, of course, no. Specifically, problem 2. It's to connect the algebraic solutions to the graphical solutions, and also understand the numerical side to be able to make all those connections. That's when this stuff starts making more sense. You start becoming more advanced in math thinking. You're gonna have to think like that in pre-calc calculus. You have to be able to think what's happening graphically, what's happening algebraically, how are those connected. So you're told algebraically, this is the solution to the equation, right? So if that's the solution to the equation, what's the y value that goes with this? 0. If I plug in -7 into this, I get 0. So when y is 0, where is that on the graph? What do we call that when a point has a 0 as a y coordinate? Good, think about it. X is on fire today. So yeah, that's the x-intercept. If that's an x-intercept, now algebraically, what's the factor? X plus 7. Thank you, Sophia. Good. That's a factor. That means I could divide this. I'm going to divide those two together. Once you start seeing that, then it becomes more robust. Then you know what's going on. Like, yeah, cool. I've got this, right? So that's what I'm going to do. I'm going to divide these two. I'm going to divide this by x plus 7. I'm going to do my little box thing here, because they're asking for the other factor, right? And by the way, finding other factors is going to be essential when you move on to pre-calculus. I do teach pre-calc. I teach pre-calc BC honors and that level pre-calculus. So I see both extremes. My pre-calc BC honors students can do this seamlessly, just the whole division stuff. My level pre-calc, not so hot. I want to make sure you guys are more like the pre, even though, yes, you guys are going that level pre-calc, pre-calc AB, but I still want to make sure this is a skill that's not a problem, that you guys are fine. So I'm gonna make 3 columns, space out better, sorry. All right, okay. That's x and 7, right? X and 7. Okay, cool. I'm gonna put x cubed here and -14 here. Okay, great, awesome. All right, that's x squared, we know this. That's 7x squared. Okay, because of a 5x squared, what do I combine with 7x squared to get the 5x squared? -2x squared, awesome, very good. -2x, that's -14x. Okay, and then if I have -14x, I got to have a -2x here. Then that's got to be a -2, and it checks out the end. If it doesn't check out the end, then it's not a factor. There's a remainder. And remember, you have to see if it overshoots it, then you got to do a minus. If it undershoots it, then you got to do a plus to bring it back. But it's good. We got it. That's the other factor. And look at the graph itself. It looks like it crosses at -7, right? Does that look like -7 to you? Yeah, right. But look at the other two x-intercepts. What would you say this one is right here? It's kind of hard to tell. It's between what two values would you say? 2 and 3. And the other one's probably between what? 0 and -1, right? So it's not spot on. It's going to be a decimal probably. Well, guess what? That's not factorable. When I say that, x squared minus 2x minus 2. So let's talk about it. You guys, we had this on our test, right? Let's do quad form really fast. 2 plus or minus b squared minus 4ac all over 2a. So it's 2 plus or minus root 12 over 2. Now I'm going to use a calculator. I'm just going to do it with my handheld here. 2 plus root 12 divided by 2. That's 2.73. Or 2 minus root 12 divided by 2, negative 0.73. Guess what? Now we made the algebraic connection and graphical connection. This is huge. Graphically, I see that. Graphically, I see that. Algebraically, I see that. Numerically, I see that too, because I'm working out the numbers, right? So now this is all good, right? This is all very nice. So I'm seeing all these connections. By the way, what if the discriminant were negative? Would it have crossed the x-axis? No, it would have been imaginary. If this is negative, this graph makes no sense then. The graph should have been like this then. Should have been like that, where it crosses just once, and the other two don't touch, because the other two x-intercepts are not x-intercepts, they're imaginary, right? Now we're starting to understand why we have imaginary, because they're imaginary, they don't exist. They're not real. Because the discriminant was negative. So we had that on the test too. We don't do these things. Oh, it's discriminant just because we have to do. We have to check off a box. It's algebra 2. We have to teach this to you guys. No, we want to be more intentional. We want to make sure we understand what's happening graphically. So you move on to pre-cal, you have a better understanding of this, all this math stuff, right? It makes more sense of it. Does that make sense? We're okay? Okay, good. All right. Okay, cool. Oh, that's an annoying fly. Okay. All right. So again, the rest of the answers was right here. Okay, there you go. And then the rest of the homework was what? 121 through 125. Okay, let me just show you the answers, and then I could talk about if you want me to. I'll make a screenshot of these. I didn't do a good job of posting homework answers the last unit. I'll do a better job this time around. I promise that to you guys. Those are the answers for rest here. I'll post the answers when I get a chance. Maybe I'll get a chance today to do that. So yeah, and those are part C for 820. Yeah, there's part C and D for 8125. So it's all being recorded, so don't worry. Just so you know what you're going to do for the other problems. This one here, Carlos needs to solve that equation. He sees it crosses the x-axis at 1. So all I'm going to do here is divide this by x minus 1. Here, without actually multiplying. Actually, this one, just think about. Yes, you kind of multiply here. What's negative 2 times 3 times negative 5? Negative 2 times negative 3 times negative 5. 30. Boom. Speed. The speed for that one. Oh, you're right. Yes. No, then it's definitely C. Because I like the x cubed better than the 2x cubed. How come I'm not going to do 2x cubed? Because I have x. Right? How am I going to get 2x cubed if I don't have a 2 next to any of these x's? Or 2 on the outside. So you're not actually foiling this. You're just kind of like trying to envision what's going to happen. Next up, which following could be a factor of this? Well, because you have a 5 here, you probably need a 5 at the end. So I'm probably going to go B on that one. Because, how am I going to get, all the other ones, right? It won't make any sense. And actually, if you graph it, you want to cross the x-axis at 5. If I plug in 5 here, I get 125 minus 9 times 25. Yikes, plus 19 times 5 plus 5. I think it works itself out, if I'm not mistaken. 9 times 25. 125 minus that number. Plus 19 times 5. Yep, it works out. Here, 124. Now divide this by a factor chosen preceding problem. Okay, fine. It works out. You're good. And the resulting factor, and use it, and the resulting factor, find all the zeros. So you have to then break it down even further. If not, then you have to reconsider whatever. It's fine. Or do quad form. Or for the end. And then here, consider this equation where the factors just factoring, where the solutions, blah, blah, blah. So when the ratio between the factors and the solutions, they multiply together. That's what I think what you have to say for that one. Yeah, and then 3 and 2 factors is 6, while 5 is the factor leading coefficient. Is that what they're asking? Yeah, okay. So cool. I think we're all good there. All right, so that covers all that homework. Okay, that was very thorough. Now let's move on to the notes today. And hopefully this will help us understand this better. So everyone has the notes. So let's go to notes, guys. And you guys on your laptops up, if you can lower them, please. Laptops, you can lower them. Yeah, you can open up when we're done. And if we finish early enough, if you guys do want to hang out outside, we can. But I do have to come back because I have to see some people during white period. So, or we can stay in here. Yeah, I think about half you guys have to see during white period. So we'll just be honest, right? All right. Anyway, factors and integral roots. Okay. So let me kind of read this little blurb here. Actually, I'll give my voice a break. Gus, do you mind reading that first paragraph, please?
Sure.
Thank you.
You already know several methods for solving quadratic equations such as factoring between the square using the quadratic formula. Mathematicians have developed formulas for solving third and fourth degree polynomial equations. But these formulas are far more complicated and messy than the quadratic formula is, and they are rarely used. Furthermore, for polynomials of degree greater than 4, there is no single formula to use. For many polynomials, you can develop more useful methods than a formula based on what you already know.
Okay, good. So the key takeaway is let's get away from formulas and let's actually let's get more towards like a method or a theory and apply that method or theory. Okay. So here's like a theorem, right? It's called the factor theorem. If x equals a, so whatever a is some number, is a zero of the polynomial, then x minus a is a factor. We know this now. And so you could treat it as such. For example, if -3, 2, and then, oh boy, 1 plus or minus I root 7 are zeros, then x plus 3 is a factor. X minus 2 is a factor. And x minus each of those other complex numbers are also factors. So here, given the polynomial that you got there, list all possible linear factors of the polynomial, use only integer values for a. Okay, so here's what you can do. If you think about it, what two integers multiply so it has to multiply to 6, right? Or basically our factors of 6. So give me some numbers that multiply to 6. What else? 6 and 1. Can I make a negative? Sure. Yep. So what this means is that all the possible linear factors could be x plus 3, x minus 3, or you could do x plus 2, x minus 2, or you could do x plus 6, x minus 6, x plus 1, x minus 1. You do any of these here. Any of these could work. I don't know which ones will work, but any of those could work, just so you know. But I'm not going to do x plus 4 or x plus 5 because then you'll have a fraction that's multiplied to get to 6. So like for this one here, we have 48, right? Now 2 and 3 did multiply to 48. Are 3 and 2 factors of 48? You bet. It still happened though, some imaginary stuff. I can't know what to say about that, but at the very least, I know it worked out nicely. So okay. So let's keep on moving. The fundamental theorem of algebra. I feel like this should have been taught to you from the day you started learning algebra. But anyway, the fundamental theorem of algebra is basically saying that I'll kind of just get it. This is a lot of mumbo jumbo. I'm just going to say this: the degree equals the number of roots, complex or real, or let me say imaginary or real, because complex is everything. So if you have a degree 4, you got 4 roots. Degree 5, you got 5 roots. Not all of them will be real. Not all of them will be imaginary, but a combination could be. Or it says has at least one complex root if you have one variable polynomial. But that's what it's just saying. Degree n has n complex roots. So if I have degree 3, I expect 3 roots. Maybe one's a double root. Maybe one's a triple root. Maybe this one's imaginary. I don't know. Or multiple imaginary. I don't know. Actually, you wouldn't have one imaginary if you have real coefficients, but anyhow. So here, I expect 3 roots, right, for number 2. I expect 3 roots. It says verify that x plus 1 is a factor of it. Okay, great. So you can just do this. So do 3 columns, x and 1, x cubed, and 4. Now we know this is x squared. And if you have x squared, that'll be negative 4x squared, because you have to have negative 3x squared here, right? So x squared negative 4x squared gets you negative 3x squared. Negative 4x, negative 4x. There is no x in the equation, so we have to put a positive 4x. That's a 4. And just to check that 1 and 4 multiply by 4, it does. And there you go. X squared minus 4x plus 4. And can I factor that? Sure. X minus 2, x minus 2. X equals 2 is a double root. That's what's happening there, that one. All right. Take a little pause there. Okay, rational roots theorem. Just tells us that given a polynomial function with integer whole number coefficients, so your coefficients are whole numbers or integers, so it could be negative numbers also. A list of possible solutions can be found by listing the factors of the constant over the factors of the leading term. So what you do is this. You take all the factors of the constant and divided by all the factors of the leading coefficient. Okay. Cool. Good, right? So in this case, what am I going to do? Where are all the factors of my constant? What's my constant here? So I'll put plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. It's a coincidence, but what's my leading coefficient here? Same thing. Plus minus 1, plus minus 2, plus minus 3, plus minus 6. Now we actually have to divide this out. So what I'm going to do is divide all these by this right now. If I do that, what happens when you divide a number by 1 or negative 1? Does it change? No. So definitely I'll have plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Now, what if I divide all these by 2 now? What if I divide all those by 2? I get 1/2. But what's 2 over 2? We already have that. 6 over 2 is 3. We already have that. But 3 over 2 is kind of unique. So I also have plus or minus half and plus or minus 3/2. Okay. Now let's divide all those by 3. Good. Yes. 2/3 and 1/3 will be unique, but 3 over 3, 6 over 3, I already got those. That's 1 and 2, I already got those. So you want to find other terms that are unique, or other numbers are they're unique. So plus minus 1/3, plus minus 2/3. And then if I divide everything up top by 6 now. And we already did 1/3, we already did 3/6, 1/2. Yeah, so plus minus 1/6, right? That's also unique. So what this means, so what does that represent? Because I know sometimes we get lost when we get too caught up in the calculation. What this means, any of these numbers here can be an x-intercept of this graph. So any of these are possible. Nothing else outside of this will be an x-intercept, unless if it's like imaginary or like a radical or something. But as a rational, you guys know what rational numbers are? You guys know what that means? What's a rational number? This is the part that we have to actually come back to. Then remember?
Like a number that like the decimals are infinite.
Yeah, or the decimals terminate, right? So, but actually, right, they terminate or they're repeating. So like, for example, what's 1/3 is a decimal, guys? 0.3 repeating, right? What's 1/4 is a decimal? 0.25. But √2, if we're playing √2, is there any end to this? And is there a pattern to it? No, that's not rational. How about pi? 3.14, a bunch of random stuff, right? These are irrational. So rational means ratio. Has to be a ratio of 2 integers. 0.25 is 1/4. Those are 2 integers. 1/3, 0.3 repeating. Those are 2 integers. So it terminates or repeats. These clearly terminate or repeats. So any of those could work. Now, here's the really crappy thing. There's a possibility that none of those work. That none of these would be the x-intercepts. And so you'd have to test these, like you'd have to divide this by maybe x minus 1 or x plus 1 or x minus x plus 2. I'm not gonna make you guys do that because that's really cool. I actually used to do that, by the way. My tiles were 19 years ago. I used to make my students check these to see which of these worked to break down this polynomial. Now I just tell you, hey, just use graphic calculator, tell me one of the x-intercepts, and then use the division to break it down further. Jack, go ahead.
How do all some of those work now?
So these are just possibilities. That's part of the theorem. Okay, how they would not work? That means that the other zeros are irrational, have radicals in them, or they're imaginary. That's a possibility. Because if you multiply two imaginary roots that are conjugates, like 2 minus I and 2 plus I, like x minus 2 minus I, x plus 2, and you put them all together, then you would get back to this polynomial. You could. That's a possibility that could happen. Kind of crazy. Okay, remainder theorem. And look at the notes in interest of time. Let me just end with page 2. We'll just pick this up on Monday because we actually have time, because I don't think we're gonna add on another because then we finished off the other notes on Monday as well. And I don't think we're gonna add any more. Maybe add one more section and then we'd start preparing for our last test on the 15th. So let's look at this one here, remainder theorem. The remainder theorem states the following. That if you have some polynomial, right, and divide by x minus 5, whatever the remainder is the same thing as this. It's a little confusing at first, but what it means is that so let's go back up to the homework again. You guys remember we had this here when we worked this out? Actually, I'll show you the answer key as well. What do we get for the answer? Yeah, it was x squared plus 4x minus 2 equals -3. Okay, so remember we had this as our answer for part C. We had 3 as a remainder. -3 as a remainder, my bad. What this means is that f of 3 will equal -3. So what's happening here? You have f of x divided by, they say x minus c. F of c will equal the remainder. That right there is remainder theorem. That's actually the best way of writing it. They're a little confusing with their wording, I think, personally. So what's f of x here? F of x is all this junk, right? And that's x minus c. So if c is 3, if I plug in f of 3, I should get -3. Well, let's plug it in. 3 cubed plus 3 squared minus 14 times 3 plus 3. If I work that out, I get 27 plus 9 minus 42 plus 3. I should get -3. There we go. Should get -3. So it's the same thing. So going back to the notes, they say use the remainder theorem. Check which possible roots is an actual root. Really? I really don't want to do that. Okay. I'm gonna cheat. Let's go to Desmos. I really don't want to test all those. It's a pain to do. So 6x4. I just my short-term memory is terrible, so let's see here. Plus 7x cubed. We're just gonna cheat. Minus 36x squared minus 7x plus 6. Okay, where's it cross? Okay, definitely crosses at 2. So what this means is that if I were to plug 2 into this, cube 2 of 2, if I were to work all that out, mind you, you'd have a calculator. 6 times 16 plus 7 times 8 minus 36 times 4 minus 14 plus 6. Oh boy. 96 plus 56 minus 144. That'll be minus 8. Yeah, they do cancel out. Yep, they cancel out. You get 0. We're good? Yeah. And then fine for this one, find all roots. Well, now I know one that works. We would just do this. We'll do the Polydoku thing again. So 4 columns. X, and because 2 worked, because 2 is a 0, then x minus 2 is a factor. Okay, so that's 6x4, and that's 6. What do you multiply to x to get the 6x4? What do you guys think? 6x cubed, you had 12x cubed. Then you'll need 19x cubed. So that's 19x squared, -38. X squared. So you need a positive 2x squared here. 2x, -4x, -3x, -3. That all makes sense. So then this is your remaining polynomial. Unfortunately, you can't do factor by grouping here. So you got to break it down again and find another x-intercept. But now in this case, I'll probably try 3 or -1 or 1. But looking at the graph should be kind of telling. It crosses at -0.5, right? And -3 and 1/3. So you can actually break it down even further by doing the Sudoku thing or the Polydoku thing again. You can break it down again by doing this. Again, I cheated by having the graphing calculator. Otherwise, you got this by trial and error, which kind of sucks. But I did see x -3, so I'll do +3. Because remember, -3 is also a root, so x +3 is a factor. Right? So 6x3 and -3. So 6x squared. That's 18x squared. So that's x squared. And then this has to be x. So 3x. 3x, this is -x. -1. If you factor it, I think you get 2x + 1 and 3x -1. Yeah. So x equals -½ or x equals 1/3. If you, I mean, yes, the factor might be as easy. You have to probably do a little work with that. But that's what we're working our way towards, is breaking down this polynomial. So now what we've done, we could do this without a calculator. We could do this without graphing. You have to do a lot of guesswork with all the possible zeros, which was a pain in the ass. I'm not going to force you to do it. That's crazy. So I use a calculator and get that, and then I break them first. I did cheat a little bit, but you could see that it is possible to do these from algebraic techniques. There's all these theorems that come out that can work. So, all right, I think I'll stop there because I think you guys get the idea. The rest is kind of repetitive. I still think you guys could do the homework. I still think it's possible. So, I think maybe I'll drop the homework by a little bit. Let's see. Let's take a quick gander. I think 138's a good one. I think 134 is a good one too. I think 148 is a good one. And 154. So I'll do 4 problems. 134, 138, 140, and 154. I'll update Schoology. So I'm gonna write this down. All right, I think we're all done. I'll run the board. $138, $148. Yes. Yes.
Sorting, letter B, 118. I did it with long division since